Okay, as promised, today I'm going to show how to implement uh, your own random variate in, first I'm going to do it in SimKit, and then I'm going to do it in the Python DeskPy. So, um, and you're only responsible, of course, for the platform that you're on. So, um, and it's as I might have alluded. I mean, if you're um, my preference is Java. I mean, if I have a programming task to do, 9 times out of 10, I'm going to do it in Java. Why? Because that's what I'm most comfortable in these days. Partly because in many of the programming tasks that I have, it's the best one for that task. And there are other ones for which Python is actually a preferable one. My recommendation to you is to learn both of them. Why? Because Python, for all of its warts, in my review, is if not the most popular. At some point, it's going to be one of the most popular languages. Now, popularity isn't everything, but in certain areas, particularly uh, places like machine learning, data mining, things like that. The people who do that seem to be using Python a lot. For Okay, so in other words, it would behoove you to learn that. And if you're only a Python person and you have certain programming tasks, it would behoove you to check out Java. For a number of reasons, but anyway. So today, but I'm going to do it in both, and as I said, I mean, I can, uh, uh, when it comes to things like this, you have to be uh, mindful of kind of who you're getting the information from. So if there's somebody who only knows one language, and is saying, okay, this is the best, but hasn't worked with the other ones, then I take what they say with a grain of salt. Why? Because it's just what their preference is. I feel that I have a right to complain about both Java and Python because I program in both. I've done a lot of serious programming in Java, more so than Python, but the DeskPy implementation of event graphs in Python is a major program. I mean, it's not a small little thing. And I'm I'm mindful of the fact that my Python skills are minimal compared with my Java skills. Uh, Nevertheless, I've been able to implement this thing, which is fairly I think it's a pretty good one. But having said all that, I will stop breaking my arm, patting myself on the back, and move on to what it is we are doing today, which is implementing this. I'm going to implement this composition method. Couple reasons for that. One, the takeaway is that this is a template for how you're going to be able to implement your own version of random variables. And the second is that if you are really seriously looking at what this kind of landed on, which is this composition method, the fact is that this there's no way this should work. So uh, so how can one convince oneself? I mean, well, you could apply the math. There's a mathematical proof you could do that would show that this, in fact, produces the correct output, the correct distribution. My experience is that's never convinced anybody. So instead, what I'm going to do is implement it, generate a whole bunch, and do a histogram to show what shape it is. If it's not right, then the shape will be kind of weird. if it's right and the shape turns out to be roughly what this looks like, then that's evidence that this is actually something which is worthwhile. Okay, so and then the second takeaway, of course, is how to actually do the thing, or maybe that was the first one. Okay, so let's okay, first we're going to do it in Java. So okay, I hope everybody can see this. Let's put it in a separate its own package. So moves mv302.random, and as I said, there's so I'm going to call it a triangle composition. Now, one of the things that I don't think it was on the slide, but and it's kind of optional in the Java version, for a variety of reasons. I like to tack on the suffix variate to the name of the class, just to indicate that yes, this is a variate. In the Python version, I don't do that, but anyway, the super class is going to be the random variate base. Variate base. Okay, and that's an abstract base class that does at least a little bit, and we see that it's not abstract and does not override an abstract method. So what we do is we simply say implement all abstract methods, and we see that the three abstract methods we have not implemented are generate, set parameters, and get parameters. Now, for these random variate ones, unlike the event graph component versions we've been writing, you only want a zero argument constructor. And in fact, for this, since there's nothing to instantiate, we can just let Java provide us with our zero argument constructor. But what we do want is we do want our three parameters. And what are our three parameters? Our three parameters are the minimum value, the maximum value, and the mode. Mode, you know what mode is. So we do these as regular parameters. It's going to be a double. I'll call it min, max, oops, and mode. And as with the other ones, we can we want to have setters and getters. Let's see. No, we don't want them protected. We want them private. I want to select them. I'll put it as the last method. And now I'm gonna do this a little bit unsafe, as it were. Ideally, we want to sort of do a little bit more checking on our parameters. But okay, so that's kind of the first thing. The second thing, okay, we have these three methods to the easiest one is the get parameters, and notice that the get parameters is going to be an array of objects, and we want to simply return our parameters. And you can use the variables or the getters, it doesn't matter. Okay. And then the other thing we want to do is we want a toString. I said that was optional, but it's so we want to return a formatted string. Let's call it we want to just sort of list our parameters. And I'll list them with like 2 decimal places. And the convention on there are 2 conventions. One is the minimum mode and maximum, and the other is minimum maximum mode. Both of those exist out there, though just where I learned it, this is the way we have it. Okay, so we've done our getter for the parameters, and now a lot of the work has to do with setting the parameters. Because here's the thing: remember, notice that this is a varargs coming in, and we can treat it like an array. So we need 3. We need all 3. We're not going to allow any default ones. So the first thing we want to do is if the length is not equal to 3, then we want to throw an exception. And what do we need? We need 3 parameters. And how many were given? And as we talked about last quarter for those in Java, whenever you throw, first of all, you want to throw exceptions as soon as you can, because if I don't give you 3 parameters, there's no sense in even going forward. But don't just have the error. If you've ever gotten an error in running a program and it doesn't say what the error was and what you need to do to fix it, I mean, at the very least, say something like this: I need 3 parameters. This is how many you gave me. So you know how to fix it. Now, the other thing is that, okay, so now we need to check the type. So I have 3 parameters, but they could be, and now these are objects, so these are going to be the object wrappers. So I'm going to be a little bit crude here. And so I want to test if params 0 is an instance of is, and here's where I know I want a double, but I want to test for number, because remember, number is the superclass of all the object wrappers. And this way, if you give me an integer, I can handle it. If you give me a float or a short, or if you give me any type of number, I can handle it. And so the first one is I'm going to set the minimum. I need to cast this to a number, and then I want to give the double value. I want to do the same thing for each of these. And then here. Oops, I need another parentheses. And now I'm okay now, and what I want to do is otherwise I want to throw an exception in each of these. I'm going to skip over that just to get things going here. I'll just run them all in the same place. So So remember, one of my dictums is um, to run a program as soon as you have something that is kind of runnable. Okay, so here's what we need to do. The first thing we need to do is we need to tell the random variate factory where to look for this. So what I want to do is to add search package, and the search package is the package it's in, whatever it is. So I want to put in that the package that my random variate is in. It can be anyone arbitrary. So once I've done that, then I can get my instance. So when I can give it the name of the class, and oops, and now I got to, if I fat finger it, it's not going to find it. And notice that I called it variate. If I leave the variate off, then it'll find it anyway. So let's see, let's say 2.1, 5.2, and 4.0, say. Excuse me. All right, now all I want to do is verify that that it's found it, and it's gotten the right things. And now now here's the thing. I know it's not going to find it, so you're going to kind of that's it's going to say can't find it. Okay, so let's see. Random variate class not found for triangle composition in the get instance. All right, what the heck happened? Well, what happened is that in order to find it, it has to be compiled. And if you notice here, you see that little I don't know what that little icon is. That indicates that this has not been compiled. And so I need to compile it. Okay, so if that happens to you, then the first thing to check is has it been compiled? And now when I run it, okay, it found it. It found it, it got the right parameters in. That's all I'm checking. Okay, so make sure that it's compiled. All right. Now there's some more to do for the parameters. If it's not a number, I want to say, hey, that should have been a number. As of right now, what it's going to do is it's just going to, let's see, well, what's going to happen? What's going to happen if I give it, just to, you want to sort of check and see these kinds of things. It's going to give me an error. Well, didn't give me an error because it didn't recompile it. Here's how you can actually sort of make sure that it always gets compiled. If you go to properties, your project, and you say compile on save, if I set that, okay, now I'm going to get an error. Yeah, I'm looking for the error. It should have. Okay, so interesting. It gave me a 0 instead of the last one. I don't know why it did that, but anyway, we'll move on from that. Okay, so all right, now the next finally we're going to get around to implementing the generate method. That's and this is true for both of those. So what we want is we want to implement this method. So and we can just sort of literally take it. So we want to generate U and V. I'll just sort of take those literally. Oops. Okay. Now, in the SimKit random number, guys, it's the call is draw. And the name of the thing is it's a protected variable called RNG for random number generator. Okay, so putting these things in the way. All right, so all right. So we're going to use the V for the testing. So if V is less than, okay, what was that thing? It was the mode minus the min divided by the max minus the min. That was the deal. And we're going to return the minimum plus the mode minus the min times the square root of u. And we need to import square root. Else, if not that, then we want to return the other one. And that is max minus mode times the square root of 1 minus u. Again, I'm just simply implementing, I don't know why PowerPoint closed, but okay, so I'm simply implementing this directly. Return. All right. So now, now the thing is, let's just sort of generate a few. Just let's maybe generate 10 of them. And hopefully we'll get some numbers. Okay, so now are these good numbers? I don't know. How can we find out? Well, let's dump a bunch of them. Oh, how many should we do? 100,000, a million. And let's let's see. I'm going to just put this in my home directory just because. Okay. Oops. Sorry. Okay, so now we're going to not do the system out. We're going to just do them to out. And hopefully we have, okay. Okay, so it took a little longer than I thought, but let's just sort of check and see. Okay, so there it is. And okay, so how can we um, turn this into, check and see that this is a decent histogram? Well, I like the package R. Your mileage may vary on this, but I find this to be a very useful one. So I'm going to suck in the data for that, and that was and then all right. So now I can create a histogram by just saying hist, and then turns out that it's going to read this in the first column. I want to do a false frequency. Let's have 50 of these sales, and then the name is, this is going to be the title. Oops, triangle. I think that's, oops. Okay, so here's the histogram of uh, of what that was. And as you can see, um, that looks pretty much like a triangle. The mode is roughly at 4. It goes from a little over 2 to a little over 5. So basically, that verifies that in fact it did it. Okay. That. All right. Okay, I'll commit this when the class is over. So that is how you do it in SimKit. Just to review, subclass random variate base, define your parameters with setters and getters, write your get parameters, write a toString to make sure your stuff is getting in there okay. In the set parameters method, do some checking on this. What I need to do here is throw an exception if that's not the case. And then finally implement your generate method and then test it out. Okay, that's the SimKit one. Now let's look at the Python one. So here's our, let me make sure I'm up to date. Okay, we're up to date. So I'm gonna put this in, let's call it random. And Zoom keeps putting stuff in the way here. All right. All right. So what do we need to do? Well, one of the things is from SimKit rand, we want to import random variate. Okay, so we define our class as a triangle composition extending random variate. And unlike the Java one, I don't put the variate in. Okay. So in our constructor, now here's one of the differences, is that we want to give our parameters as keywords. So we define our constructor. Okay, and let's set them to be nan. Oops. Just because we want to be very. Okay, so we have these set as keywords. We want to call the superclass constructor as well. And then we define our keywords as instance variables. So self min is min, self max as max, and self mode as mode. Now we do want to define a generate, but for now, before we do it, let's just do a pass for now, because the next one is to do our toString, which is called RPR for some reason. And just as with the other, we want to kind of return, and there are a number of ways of doing the parameter things. One is we can have our self min, in these little, I don't know if you're self max and self mode. I think that will work. All right, and before we go too much further, again, as before, we want to test it. So we want to test. So, of course, we need to, now here's the thing. We actually don't need to explicitly import that. What we do need to import SimKit rand, import random variate. The other, now one of the things that we need to do is with the module. So from, let's see, now where do we, the import lib, we want to import. So, import lib dot import. And then what we want to do is give it, as before, the module that it was. This is Stephen T. Seems claim it has no effect. I thought that's, oh no, we got to import lib. Import module, sorry, yeah. I want to import the module. And so this will allow us to use our instance method, or which is actually a static. So we give the name. Now for this, we need, since it's in a different module, we need to give it that module. And then finally, we need to give it the values. So I'll give it the same values as before. Oh, and we need to give it as keywords. That's it. Okay. And so what we're looking for is, all we want now is to make sure that the parameters got in there okay. And of course, what is it?
Looks like the name of MV3302 isn't correct in the random, in the triangle.
MV3302, thank you. All right, so it found it. And the advantage of this is that now is that we don't have to explicitly import it. We can just do this by name. So the advantage of that is that if you're reading in these from a data file, these are just strings. So I'm just giving it strings, but it's coming out with a random with the actual class that I have. And that's the advantage of that then is that I can write code. And if I want to change things up, then I can just change a data file. That's kind of the way to do stuff. All right, so finally I need to do the generate thing. And as with the SimKit one, there's an instance variable in the superclass called RNG, and we need to do it with the self. So I'll do the same kind of thing. So it's self RNG. And since this is this is actually the Python random, so its method is called generate, not generate random. Badly named because generate is a good name. This is not. I'm biased on that, but okay. So now the same deal. So if RV is less than, and what we want is the self mode minus self min divided by self max minus self min. If that's the case, then we want to return, okay, self min plus self max minus self min. I'm sorry, not self max, self mode minus self min times the square root of u. And we need to import square root. Okay, else we want to return self max minus okay, so let's and as before, that is simply a direct um, translation of this. Okay, so let's see how that worked. So let's just sort of print a few. Oops. Okay, so it's printing them out. And then now we want to print to, we actually, now what's the, okay, so I think it's say open, we have to open, and I'll, one from the Python, and we have to say we're going to write it as an F, and then move all these over, and then oops, number, oops. So, no, that's, let's see, I think, what do we have to do? We have to do something that sys out. So we have to import sys. Uh, if we do that, and then and then close it up. Let's call this. Okay, all right, looks like it actually got in there. And so let's go back to R. And so let's see. Oops. What the heck did I call it? Triangle Python. Oops. Yeah. Triangle Python. No such. Well, there it is. Open the. I cannot open the connect. What the heck? There the file is. It's right there. Looks the file that's right there. I don't understand. Okay, why is it? I mean, all right, let's try something else. Let's. And if dish has length and only the first element, what the heck? I have no idea why this is doing that. Is it? It read this one, it read it okay. What is the problem here? Is there some garbage in it? Nothing I can tell. Go figure. All right. Oops, Python. So just as with the other one, I mean, we have a histogram and it looks pretty linear like that. What did we see? Zoom keeps putting on. That was only 100,000. Let's do 1,000,000. Okay, a little smoother. Okay, so what's the point? The point is that now there is no impediment whatsoever to your being able to use any random variable that you can come up with a way to generate from, whether it's in the library or not. If you come up with a more efficient method than what's in the library, which is quite possible in many cases, or if the library doesn't have the random variable that you want, then now, and especially after we talk about the acceptance rejection method next week, you'll have the methodology to be able to create a way of generating it, uh, theoretically at least. And now you have at least two specific ways to implement that. And the thing is that these are first class, these are both first class objects. That is, all of these, like in the Java one, this can be used in any one you want. In fact, let's just to kind of put a point on that, let me go back to the Java one. And be lazy here and sort of get all these here. All right, so let's okay. I don't know what the heck is going on with this, but so see, we can take that, and because it's a random variate, we can just shove it into our arrival process. And not only that, something weird is going on. This should not take 3 seconds. But let's stop after 5 arrival events. Okay, so and notice that the arrival process did not have to be recompiled, and it was able to just kind of use what was there in the first place as well. And the same thing holds for the Python version. Let's hit I'll put it right in here. So if we import our arrival products, what did I call it? MV classes, import our arrival process. All right, let's do the same thing. And hopefully, well, then we see that it gets guts in there. Oh, it's generating all those other ones first. And then, oops. No, close the file. Let's not close the file. In fact, let's Let's skip all this here. Okay, so there, and then just the same thing. Let's import event list. Run it verbose. Oh, let's stop on 5 arrival events as well. Reset. Start simulation. And we see that it actually works, so that we're using the random variable that we created to just shove it. So that's why it's a first class citizen. Okay. So so that is it for this. And now at some point, as you might guess, I'm going to be asking you to do this. And so you might want to refer back to this class, this video, when it comes time to do that. In the meantime, there is nothing more for this week.